Hello everyone, I'm Mr. Patel and welcome to my channel SE108. Today we will explore some key concepts of software engineering and that makes a real difference in your project. By the end of this video, you will have a clear understanding about how softwares are developed. If you are passionate about software development, don't forget to like, subscribe and hit the notification bell icon so that you can stay updated with our latest videos. So let's dive straight into it. The question is, what is the difference between software engineering and software programming? So let's discuss one after the other. What is software engineering basically? Software engineers are the one who analyze the needs of the client and the company together with the needs of the users to develop an idea for a software system that can deliver what is needed. Testing and maintenance of the system are their responsibility, and they usually relegate the smaller tasks to the developers or the programmers in order for them to free some to supervise the overall construction of the system. Now comes who are the programmers then? So the programmers are the one who translate the software engineer's instruction in the lines of code to the computer which computer can understand and follow. They are responsible for finding and fixing bugs within the system. A programmer's responsibility can involve correcting problems that come in testing, maintaining documentation, and incorporating contingencies such as error messages into programs, training, and end users. Now, we have discussed what is software engineering and the difference between them. But now, how does it deal with different aspects like team management, complex systems, and long lifespans? So let's discuss that. It deals with team-based management by using Agile and Scrum, like it is a framework which enhances coordination among teams with the inclusion of regular communication and well-defined role. Another one is version control, task management, CI/CD code reviews also. Then comes the complex system. So how it deals with complex systems? It uses modular design, architectural patterns, and testing and documentation. So it's like thorough testing and documentations. Documentation provides for reliability and gives teams an understanding of how systems work. Now comes long lifespans. So they are dealt by maintaining code and refactoring, backward compatibility, automation, and DevOps. It's like continuous integration, deployment, and automated testing maintains the product more smoothly and uniformly. Then comes the regular updates, security patches, and updates pave the way for the product's long-term visibility. We have discussed how it deals, what is the difference, and all of those things. Now, the main and the most important topic is how they are developed and what is the process of developing it. So it's like a life cycle. It's a process from planning to maintaining the software. Let's discuss that. First is the requirement analysis stage. It is the first step in the process of software development wherein one needs to understand the requirements and based on it gathers the requirement which take place. It is done by normally identifying needs, objectives, and constraints of the project. Then comes the design phase. This is actual architectural development of the software and its user interface. It is a stage at which it is defined how the software will work and how it will be interacted with. Design involves wireframes, prototypes, and system architectural diagrams. Then is the implementation phase. This is the most crucial phase of software development, succeeding the design phase. Whatever was strategized in the design phase will be implemented here. Whatever planning was done during the planning phase and whatever designing was done during the designing phase is implemented in this phase. In this phase, the physical source code is created and deployed in the real world. Then comes the testing. It is done by the quality assurance engineers. The developers utilize unit tests when determining small parts of code, for example, functions or methods. These tests help in the identification and subsequent bug fixing within their isolated elements. Then is the deployment phase. Before actual deployment, the development team reads the target environment for setup at either on-premise servers, infrastructures in the cloud, or at the end users. These may include installing servers and database to set up the software dependencies. Then there is the maintenance, and this is the last stage of development. Maintenance is the stage where bugs are fixed, features are updated, performance optimized, and adjusted to the new requirements and environment. All this keeps the software functional, secure, and efficient for a longer period. Now, we have discussed how it is developed. So, what is the scope of software engineering in real world? Let's discuss that. The span of software engineering is huge and keeps on increasing due to rapid development in technology and ever-changing industrial demands. Software engineering shapes the digital landscape in everything from requirement engineering and process design to AI cybersecurity. While new technologies and approaches are continuously being developed, many opportunities have opened for us as a professional to innovate and take up impactful projects pertaining to almost all industries. We have discussed about the scope. Now, how these software are developed. What are the techniques and notations which are used in developing these softwares? Let's discuss that. So, first is the UML diagrams. These are visual models including class diagrams, sequence diagrams, use case diagrams, and activity diagrams that help depict the structure and behavior of the system. Then one more is Gantt chart. Gantt chart is used for project management design, for task scheduling, and process tracking. Flowcharts is also a technique. It's a systematic use to depict workflow or sets of processes or decisions based used for depicting flow logic. Although there are data flow diagrams, spot chart, wireframes, state diagrams, and many more. Let's discuss some about state diagrams. State diagrams are the objects graphically represented through states and transitions, very helpful in understanding dynamic behavior. It's like what is the flow of the system and how the system will work in what flow. So for example, there is a system of school or college. So the first state would be the login state, then comes the student profile, then comes the grade. So all this flow is depicted in the state diagrams. So these naughty notations and diagrams provide a clear pictorial representation for various aspects of software projects regarding planning, design, and communication. So that's all for today, guys. Thank you for watching me patiently, and in the next session, we will be discussing some topics about software cost and maintenance. Thanks again. Thank you.